So easy. What's the formula of force? 1 by 4. Formula of force is what? This one, right? 1 by 4 pi E naught U by Q naught R square. So Q cancel, Q naught cancel, so this is remaining, right? So you can write in vector form like that, right? And as I said already, if you write in vector form, you write what? Your unit vector. Always remember, whenever you write an expression in vector form, you write the unit vector. Is it clear? Now, if you see in the textbook, there are many properties of electric field. So I'm not going to discuss all. We have more than 10 properties. So some important 4 points I'm going to tell you. First point, it said that EF, I'm writing EF means electric field start from positive charge and end at negative charge. How? See, suppose this one positive charge and here one is your negative charge. Yeah. So your electric field will move like that. Yeah. Fine. So electric field will go always from positive to negative. Start with positive and it end in negative. So next is what? Electric field do not form closed loop. Closed loop, see, closed loop means suppose when this you can see that it start from positive, it end with where? Negative, right? It end where? Negative, right? Means it doesn't form closed loop. Closed loop means suppose if it start from positive and it come back to positive. I'll get my point. Suppose this charge start from positive and it again come back to positive, then I can say it's closed loop, but it's not closed loop because positive charge start and coming to what? Negative charge. Magnetic field, but magnetic field, you'll learn afterward. Magnetic field, they form a closed loop. Okay. Now, your third point, sorry, electric field are perpendicular to the surface of the charged conductor. Obviously, suppose if I put one conductor here, they will be perpendicular to the uh, conductor. Okay? The electric field will be perpendicular to the conductor. The last point said that very important. Tangent to any point on the electric field given the direction of electric field. What it means? Suppose this, if I draw one tangent from here, right? I hope you know what's tangent. This tangent, these are electric field direction, right? This tangent will give you the direction of electric field. Yeah. Again I repeat, if I draw one tangent from this side, yeah, so this tangent will give the direction of electric field. Is it clear? Now this is all about electric field. Then yeah, your next topic is about electric dipole. Very important topic is also. Now, what's electric dipole? Is what's written here. A pair of equal and opposite charge separated by a finite distance. Separated by a finite distance, okay, is called electric dipole. Always remember one thing: electric dipole means two opposite charge, plus minus minus plus, not same charge. Are you getting my point? Is or not? So electric dipole, always remember one thing: it should be opposite charge. One should be minus, one should be plus. Then only we can say it's an electric dipole. Now next is what? Electric dipole length. Electric dipole length is nothing. See, look here. Suppose this distance from here is a distance. From this distance is a. Yeah. So what is the total distance? Is yeah. Actually, electric dipole means the total length of the dipole. Clear? So electric dipole means what? The total length. Total length is what? 2a vector. This is a vector quantity. Is a what? Vector quantity. Now, your next is electric dipole moment. See, what's electric dipole moment? Electric dipole moment is the simple as a product of either two charges. Product of what? Either charge. Clear? So electric dipole moment. Electric dipole moment means what? Product of either charge. So this is the formula. Electric dipole is a vector quantity. Q means charge, total length. So you have to know this formula. Okay, in some derivation we're going to use. Okay, electric dipole moment is what? P vector is equal to Q to A vector. Clear? And its unit is centimeter. Clear? Sorry, no, so column meter, because this is column charge, right? Column is meter. Clear? Now one thing you have to know is that the total charge, okay, the total charge is always 0. Obviously you can see plus minus, the total charge will be 0, right? Clear? And this is very important, total electric field is not 0. Electric field will not be 0. Okay, now always remember one thing, that if there is one charge there will be one electric field, if there is two charge there will be two electric field, if there is a three charge there will be three electric field. So 4 charge means 4 electric field. So what they said that total electric field is not 0, okay, due to different position of vector. Obviously electric field cannot be 0 here because different position of vector. Clear? Now see about vector, okay, about scalar quantity and vector quantity, I hope you have learned in class 11. Okay, now we're going to start with some derivation. Very short derivations are there. Try to just, I'm going to explain the mathematical part only, how it works. Yeah. Now it's given what electric field at a point on the axial line of electric dipole. Now first, for any derivation always try to understand the figure. Clear how it works? Now can you see the figure? I'm taking two charge here, minus q and plus. Why the opposite charge? Because it's a dipole, because dipole means opposite charge. Clear? So distance between these two a, this is a, and total is what, dipole length is 2a. Clear? And what's p? See, listen here, p means here we're going to find out the electric field. For point p we're going to find out the electric field. Are you getting my point? So as I said here, how many charge are here? One charge, two charge. So how many electric field will be there? There will be two electric field. Clear? E2, E1. Is it clear? Now the first, see, the first point, if you have seen your notes and this and that, the wording are given, so just go through there. Okay, so in short I'll explain to you. This E1 means the electric field due to this charge plus q. Clear? Electric field, clear, electric field due to this charge plus q. Clear? So from where you got this formula? From Coulomb's law, right? Remember Coulomb's law formula is what? 1 by 4 pi epsilon naught. Clear? q1 q2 your r square. But listen here, where you see, if you see this formula and this one, we're using only one q. Why? Because we are dealing with only one charge, not both the charges. Clear? We are going to deal with both the charges separately, not together. Have you done point? Now r square means for the distance. So can you see the distance here? We wrote here bp. Clear? Why we wrote bp here? Obviously we're going to find out the electric field here, right? We're going to find out the electric field here, so the distance should be from where the charge is. Clear? bp. So bp is what? Is on the full length. So full length what? This r. Clear? So it should be from the origin, right? O is the original center, you can say, right? So we have to determine the electric field from here. Clear? So you wrote what? R minus a, the full length, and what's the remaining length? This one, right? Now similarly we have to find out for E2. E2 is what? Which electric field? E2 is electric field for this one, for minus. Clear? So E2 I wrote same q, but it will be AP, full length. Before we wrote BP, for because B is indicate where the charge is, A indicate where the charge is, the position of charge, right? So AP. So AP is already the full, so we write the plus, right? Easy. R plus A. Is it clear? Now tell me here, how many electric field are there? Two electric field are there. Which one will be more stronger, E1 or E2? Listen here, E1 is more stronger. Why? Because near this point P, which charge is present? Plus q, your B, right? So E2, right, or U1 is E1, right? Remember one thing, E1 is the electric field for plus charge, again I repeat, E1 is the electric field for plus charge and E2 is the electric field for minus charge. So E1 is always will be greater because it is near the point charge. This this is where we would find out the electric field, right? It's near it, right? So E1 greater than E2. E1 greater than E2, right? That's why the net electric field, at point P, you can find out by subtracting this 2, E1 minus E2. So just we put the value E1 and E2. And what would be common here? Obviously this is common, right? But remove the common and this we got, right? Now I hope you know how to do LCM. Clear? See. After taking the LCM, we'll get this value, right? Now see, it's up to you how you will evaluate this one. You can use the a plus b whole square formula also, or a square minus b square, one time plus one time minus. So if you evaluate this by yourself, okay, I'm not going to show you. These are some simple mathematical part, right? See, so this will be a square. You can use a square minus b square formula also, a plus b minus b, or a plus b whole square formula also. Clear? After using any formula, you will get this value. Clear? Fine. Now just rearranging, we're not putting, just rearranging. See why we're rearranging, because we're going to put the electric dipole moment value. Electric dipole moment, remember, Q is equal to 2. What's our definition of electric dipole moment? Is the product of either charge, right? Product of what? Either charge. So we just rearranging, right? 2 Q, clear? So we just separate which one? Q2, clear? This one we separate, right? Fine, because this value is what? Electric dipole moments, P. Clear? So you got this one. Clear? Fine. So in vector form, how to write? I hope you know. See, is the vector symbol right there. And see, in any derivation, there are some special cases. So here one special case is there, is that what's given for short dipole. For short dipole, what do you mean? That means the dipole will be very small. Clear? One time plus, one time is minus, right? In the question, if you've seen, we use the dipole this on AB, right? But in some special cases, suppose if we use if you find out a electric field for short dipole, electric field for what? Short dipole means what? Your distance, right? The r is distance will be greater, right? Compared to this a. Clear? Fine. Now a, what's a? A is the distance from the origin, right? Yes or no? Clear? Now, so in this case, your a value, right, will become negligible. This equation we already got in the previous, right? Yes or no? So in this case, for short dipole, the value of a will become negligible. Okay, so negligible means we don't need to write, so this value will not write. Okay, clear? So what's remaining? R square, right? So r square, this is r square, this is r square. So r square how much? R4 will come out power to 4. So here one r is there and one here 4 is there. So if you cancel, how much you'll get? R3. So this is the equation. This is the equation for your axial, right? For how to find out the electric field in axial position. Clear? Fine. Similarly, it's very, you understand or not? You just go through once. See, these things you need to practice. Okay, first go through once. If you have doubt, please ask me. Clear? Fine. Now similarly, we'll do one other derivation, the last derivation. So now the next is electrical field at a point on the equatorial line. So similarly, before it was on the axial line, right? The previous derivation. Now the electric field which we have to determine here, it is here, this point P. Similarly, it's very easy. Okay, nothing to worry about this. Same thing here. I'm taking, this is a dipole. Dipole means what? Two opposite charge. This minus, this plus. The distance is from the origin. Clear? And this is the total length, dipole length, you can say 2a, right? Now here we are going to find out this electric field for this point electric field, to determine the electric field at this point. Clear? Now if you can see, the electric field is at here. It is from equal distance from both the charges. In the previous derivation, we have known that one electric field is stronger than the other electric field. Why? Because one electric field is very near to the point P, or we say where we're going to find out the what is that, electric field, right? So in this case, see, you can see it's in the equal distance from both the charges. So see, let's see what will happen now. So similarly we will do separately for two charges. We're going to find out the electric field for one for plus charge and for one for minus charge. Clear? So electric field due to minus charge. See, similarly, right? I hope I know it. No need to explain. If you have understand the previous derivation, this would be very easy. So electric field for point B. Clear? Fine. Now, so total electric field at point P. We have to find total electric field at point P. Now, before that, now can you see this component? Electric field B sine theta and electric field A sine theta, and electric field A cos and electric field B for this one. See, these two component, okay, they are opposite to each other. Can you see EB sine theta and EA sine theta? They are opposite to each other, and means they will cancel each other. Okay, but this one, electric field in this one direction only, because always remember one thing: electric field have only one direction. They cannot have two direction. So in the previous some properties I've explained to you that about electric field, and remember one thing: two electric field cannot intersect each other. Two electric field cannot intersect each other. Why? If they intersect each other, they will have two direction or other many direction, so which is not possible. So as again I explained to you, as I said, plus this minus, so electric field directions like that, right, from positive to negative, right? So these two field, see this line, they never intersect each other. Okay, why? Because if they intersect each other, they will have two direction or more than that, so which is not possible. Always remember one thing: electric field have only one direction. See, now see, this one in other direction, this is in other direction, not. So these two will be cancel each other because it's not possible. Electric field should have only one direction. So see, it in one direction, right? So we'll take this value only, okay, not this. Clear? Now, so these two value will be plus. Clear? Now, why we wrote E? Because since EA is equal to EB, right? Because two are same. Clear? So instead of this, you can write EB also, no problem. Clear? Because in place of EB, if I replace EA, okay, so these two will be together. Okay, clear? So two electric field are equal, but in the same, these two are equal but in the same direction, so that's why we can take this value. Okay, now in place of EB, if I replace EA, right? Yes, no, so this comes same or not? It will be plus 2, and electric field value we already know. This is the formula, right? 1 by 4 pi E naught. EA value is what you can see here. Yeah, and cos. Clear? So this value is already, we know this is a value, right? And this is cos theta, right? Now we have to find out the cos theta value here. See, before that, okay, in right angle triangle AOP, so can you see the figure AOP, or you can say, yeah, you can take this side also, no problem. You can write BOP also, your wish. Okay, now we're going to use a Pythagoras theorem here. Okay, so we're going to use a Pythagoras theorem formula. Okay, I hope you know what's Pythagoras theorem formula. Clear? Hypotenuse square is equal to hypotenuse square plus base square, right? Now in AOP, as we're using cos, what's the formula of cos? What's the formula of cos? Base by hypotenuse. So this is the base, this is the hypotenuse, right? This is the base, right? So base is OA and hypotenuse AP, right? Clear? Now AO by AP, right? Now AO is how much? Your AO is A value, right? And this is hypotenuse formula. By using Pythagoras theorem formula, you find out how to do it. We can write like, right? Actually, this is the formula, right? Is it not? So, or you can write like that also, right? Half, right? Clear? So using this, I'm writing here. Clear? So equation 1 become, in place of cos theta, you put the value here. Clear? And what will see again some rearrangement. How you got 3 by 2 is easy. This what's the power here? Here nothing is 1, so 1 power is a half, right? So how much? 1 plus half, what is it? 2, 1, 3 by 2, right? So 3 by 2. Clear? So now in place of Q2A I wrote P. Why P? P is what it called? Electric, what's that? Dipole moment. Electric dipole moment, right? We already done before. Electric dipole moment is what? It is equal to Q2A. Clear? Fine. I hope you understood. So similarly, this is the expression. This is the expression for equatorial line. Okay, fine. Now for short dipole, similarly as we done in the previous derivation, here also for short dipole, your A value will be negligible. Your A value will be negligible. See, your A value will be negligible. This value, you see, A value will be negligible for short dipole. Okay, A value will be negligible. Okay, only R value will take. So for short dipole, if A value, if you don't write, so this come right, fine. So 2 will be cancelled, and how much you 3? So this is the equation. Clear? Please go through again, and like if you have a doubt, please ask. Okay, because the derivation is not like that by looking you can do, right? You need to understand and you need to practice. Okay, so derivation is like that, you need to practice first. You need to understand and then only practice. Okay, clear? And whatever today we have done in the video, if you have some doubt, please ask me. Clear? You have to clear it out. It's not like that first you don't understand everything, right? It will take time. Okay, clear? Now see, in the previous video I forgot to mention one thing. In the previous video, like mass of proton, as I said, have a mass of proton and mass of electron. Remember, there's an instrument. It's not in the syllabus, just for your knowledge I'm telling you. One instrument is called mass mass spectrometer. Actually, this instrument is used to find out the mass of a charged particle. Like if you want to find out the mass of a proton, if you want to find out the mass of electron, so you have to use this instrument. Okay, clear? Mass spectrometer. So in a higher classes or college level, you will study about this. Okay, so this is not the end of this chapter. Okay, there's again like about electric flux is there, Gauss theorem is there. Okay, so in the next video we'll discuss about Gauss theorem, electric flux. Okay, so please go through this one properly. If you have some doubt, you ask. Okay, yeah? Because and moreover, Coulomb's law, try to understand the Coulomb's law properly, because Coulomb's law is very important, because in competitive exam they have to ask. Okay, for numerical. Clear? Okay, then thank you and study hard. Okay.